can't go through beginning of this presentation. Our team consists of Given Kim and Joey and I. Then let's start our presentation. We'll talk about our goal and our effort to achieve them by each presenter. Have you ever heard of CCD? It means colony collapse disorder. Some beehives are disappearing for some reason, but there is no clear reason. But we think we can know or predict the phenomenon using some IoT stuff. So we decided to count how many bees are coming and out to predict that phenomenon. We'll check the beehive status using our model by counting how many bees are coming and out, like this. We'll gather data of each date and make a valuable result, the like beehive status. To do this, we divide some hardware counting number of bees and linear regression. So this is a beehive, and we need to attach our box to take a video how many bees are coming and out. So I made this box with 3D printer, and there's a 10 by 10 millimeter hole to fix Pi camera. And here is my trial and error. This is a third box.
Oh, they made it themselves by using 3D printers. So yeah.
And the next step in this box is make a hole to connect LoRa antenna and make a network between LoRa and Pi to get a data that these are how many they are coming and out each 1 hour. And my part is that's it. Here is the next presenter, Given.
Yeah, so now I will show you how we develop algorithm to count the number of bees. At the time, since we could not get the data from real data from orchard, yeah, so we found a video in YouTube. So we will use that data. Yeah, so we first we segmented background and bees using threshold because backplate of inference is a height. So using that point, we found the threshold and make a binary image. But as you can see, still unnecessary background here. So P and background not segmented now. So I set all unchanged pixel to gray. So now white pixel only represent B. So we will call them now from now the foreground pixel. And using we took 50 training images with the number of foreground pixel, and we count the number of how many bees in 1, 2, 3, 1, 2, 3 human visions. And y-axis represent foreground pixels, and x-axis represent the number of bees. So we using linear regression, and we got a linear equation. These are slope and bias and R-square. So this is our first try result. Oh, sorry. Yeah. So this is the first result, and this is a foreground pixels, number of foreground pixels, and number of bees in one frame. But there were some problems that are like this: bad angle and few number of bees in the frame, and a large scale of bees. So there are a lot of noise, as you can see, like this. And these wings also are noise. So we found a new video in the YouTube. And this is a second video, and we try make a new model. Because in the first video there are a lot of noises, so we try to remove noise, and we using the method, the name of dilation and erosion. Yeah, this is the algorithm that we use. So as you can see, a lot of noise are removed compared to the first video. And using the connectivity of pixels, we filling the different color at each object, so we can separate at each object. And we found the closest and furthest pixel in the vertical axis, so we draw a vertical line. And the same way we can find the horizontal line, and using the coordinate that found earlier, so we can draw a bounding box like this. But there were still some unnecessary images like entrance or background. So we using the same method that using the before. So we can remove this unnecessary background images. So now we draw a correct bounding box like this. And we also exclude some small object under the threshold. And we using k-means clustering algorithm to separate agglomerate bees like this. These are single bees, but these are multiple bees, so we have to separate them. And using k-means clustering, we can find the centroid of a clustered bee. Using the bounding box size and the coordinate, we found the direction of single bees. Yeah, like this. And this is second result video. Yeah. There are still some problems remain because to use k-means clustering algorithm, we have to define k. The k means how many clusters are in there. So in the case, the k means how many number of bees are in there. So it's estimate to k. So we will use linear regression. And after that, if we got a centroid and direction of b, we will calculate the trajectory of bees probabilistically. Yeah, thank you.
To verify that it is accurate to count the number of bees, I have identified the correlation with the number of bees and the pixel data and conducted the regression analysis. Before that, I received the images with two noise, not bees, so I needed to figure them out. And I counted the remaining bees and I set up the data set. But there was a problem. According to a regression analysis, the normal distribution of the data must be presupposed, but neither of them follow the normal distribution. So I used the box-Cox transformation that transformed the data to better fit the normal distribution. As a result, pixel data succeeded in creating the normal distribution, but the number of bees is still not a regular distribution. I decided to solve the problem later, and I regressed the data first. The R squared is 0.653. This means there is enough explanatory power. P-value is a significant probability of an independent variable. If the p-value is less than 0.05, it is considered significant that an independent variable affects the dependent variable. In the above case, the p-value is 0, so therefore it means pixels have a significant impact on the number of bees. The future task that we have to do is to produce more accurate results with actual data. Thank you for listening.